Good day. We're looking at oxidation numbers. These are fundamental to our whole unit on electrochemistry. They're not difficult, but you do want to get a handle on it on day one. As if you understand this, life will be a lot simpler as we go along. We'll be using oxidation numbers all the time as we look at this entire unit. The rules are pretty simple. So if we have a simple atom or simple ion, oxidation number is no sweat. Anytime it's a neutral atom, that means it has a charge of 0. The oxidation number is 0. Hydrogen is usually +1. That's when it's behaving like a metal. In other words, when it's bonded to a non-metal. But hydrogen we know can go both ways, so it can bond to metals. In that case, it's a hydride, and its charge is -1. You might have heard of nickel metal hydride batteries. And so in that case, the hydride is H1-. Oxygen, when it's in a compound, is usually -2. There are things called peroxides, H2O2, hydrogen peroxide. In that case, the oxygen's a little different. Its charge is -1. And we'll go through examples probably next day where we run into peroxides. And it's just something you have to memorize. All monatomic ions, you just look up the ion charge. So if you had barium and it said barium 2+, then you know its oxidation number is 2+. If you ran into nitrogen and it said its charge is N3-, then its oxidation number is 3-. It's that simple. But if you run into a compound or a complex ion, you have to calculate. And so we'll do some examples. Unfortunately, they all seem to involve oxygen, but we'll do examples today and probably some more next day. So we look at Mg, neutral atom, 0. We look at Al3+, there's an ion, +3. Now someone's going to say, what if I wrote down 3+ instead of +3? Is that right? It means the same thing, so that's not a problem. S2-, oxidation number is -2. There's neutral mercury, so it's charge of 0. There's oxygen, O2, so its oxidation number is 0. We have 2 oxygen atoms, but there's no charge overall. So each oxygen atom has an oxidation number of 0. Polyatomic ions. Well, that means a group of atoms that share a charge. And so what you do is you start with the known information, and that means the overall charge, and also things like oxygen or hydrogen or group 1 or group 2 elements and their charges. And often the unknown charge will be a transition metal or things like phosphorus and sulfur that turn out to have different charges. So we're going to start with a tricky one. CrO4 2-. Overall charge is 2-. 4 oxygens. It's going to drag the charge down to 8-. And the chromium has to bring the charge back up to 2-. So there's our overall charge of 2-. There's our 8- charge because of the 4 oxygens. And so chromium had to take it from 8- up to 2-. And it does that by being 6+. And the oxidation number is always the charge on one atom of an element. Fe2O3, in this case we have a compound. When we have a compound, there is no net charge. That means the total charge from the metal is going to equal the total charge from the non-metal. Ouch. So there's our overall charge. Total charge is 6- due to the oxygens. 3 times 2-, 6-. We have 2 irons that are total of 6+. We divide that by 2 to get the charge on one atom of iron, and we see it's going to be 3+. So that's a 6+ because of 2 atoms, but whenever we report an oxidation number, we have to have it on one atom. And it turns out you can have fractions. We're really keeping track of electrons, but it's a bookkeeping game. So we don't mind fractions in this case. MnO2, this one's probably the easiest one. We have 2 oxygens. That's going to take us down to 4-. We know it's a compound, so an overall charge of 0. and so the manganese had to be 4 plus. So that's an introduction, 3 examples, and we will do more and more, and you'll be tested in terms of worksheets to see how you get on with this. Hopefully it's all good.